Can a machine think? Not just repeat, not just simulate, but truly think. This question posed by Alan Turing 75 years ago is more alive today than ever before. We are talking to chatbots as friends. Some call AI prophets, others call it demons. Elon Musk is building Grok to question everything. ChatGPT laughs, stammers, and responds with horrific intuition. And the global race to develop the most powerful language model is more intense than any Olympic rivalry. Today on AStellarInsight, we are tracing the full arc of artificial intelligence, from its silent origins in the 20th century math labs, through the winters of despair, and to the current buzz of 2025. So, for anyone that is out there that isn't fully aware of how we got here today, I'll take you on a brief tour through history as we trace the pulse of AI. In 1950, Alan Turing, a British mathematician and codebreaker during World War II, wrote an iconic paper entitled Computing Machinery and Intelligence. In it, he posed what became known as the Turing test. If a machine could converse indistinguishably from a human, could it be called intelligent? 6 years later, in 1956, the field of artificial intelligence was officially born. At a summer research workshop at Dartmouth College, a group of scientists, including John McCarthy, Marvin Minsky, Claude Shannon, and Alan Newell, gathered to explore a radical idea that every aspect of learning or other features of intelligence can be, in principle, precisely described, that a machine can be able to simulate them. Early AI focused on symbolic reasoning, machines using logic and pre-programmed rules to solve problems. This was GoFi, or good old-fashioned AI. Programs like ELIZA of 1966 mimicked psychotherapy through text conversation. Others like Shudlu could manipulate blocks in the virtual world using typed commands. These were like magic for their time, but it quickly became clear these machines did not understand anything. They were brittle, they couldn't adapt, they had no learning abilities. It's like building a statue to mimic a dancer. It does look the part, but it cannot move to any new rhythms. The hype was real, but the progress wasn't. And so, the first AI winter was upon us. By the mid-1970s, funding from governments and universities had dried up. Critics like Sir James Hilton in the UK described AI as useless beyond toy problems. Rule-based systems just couldn't scale to real-world complexity. A second winter came in the late 1980s to early 1990s. Expert systems once viewed as the future started to collapse under their own weight. They were hard to maintain, couldn't generalize, and failed in dynamic environments. But still, under the frost, something was growing. Back propaganda allowed neural systems to learn. The term machine language was taking root, quietly shifting the goal from programming intelligence to actually training it. Sometimes innovation goes quiet, not dead, just underground like a seed in winter. This silence is not a strange experience to science though. Fast forward to 2012, the breakthrough year at the ImageNet Large-Scale Visual Recognition Challenge, which is a huge challenge in computer vision. A team from the University of Toronto, led by one Geoffrey Hilton, Alex Krzyzewski, and Ilis Tikva, used a deep neural network called AlexNet to win by staggering margins. Their model achieved 15% error. While the next best was at 26. This was the start or birth of the deep learning revolution. And this was the idea. Feed massive amounts of data into artificial neural networks, which are basically layered structures inspired loosely by the human brain, and allow the model to extract patterns from the data. Then in 2017, Google researchers released a paper entitled Attention is All You Need. It introduced a new architecture, the transformer. This architecture in simple terms, laid the groundwork for models like BART in 2018 by Google, GPT-2 by OpenAI, GPT-3, ChatGPT in 2022, GPT-4 in 2023, and now GPT 4.0. We had officially moved from coding intelligence to growing it. But with these advances, of course, came new questions. Are these models really thinking, or just statistically guessing? Alan Turing once reflected, instead of trying to produce a program to simulate the adult mind, why not try to simulate a child's instead? And that's deep learning. Not perfection, but its growth. 2025 is buzzing with AI headlines. And here's your roadmap. OpenAI in May 2024 dropped GPT 4.0, the Omni model, and it is multilingual, meaning it understands. It sees, hears, speaks, and responds instantaneously. It can look at a photo and describe it, hear your voice and pick up emotions. It can analyze images in real time and even speak naturally, complete with giggles and hesitations. And now you can actually build custom GPTs. People are making AI chefs, coders, prayer partners, even therapists. Elon Musk's AI startup launched Grok, integrated with X, formerly Twitter, and it's raw, unfiltered. The thing got attitude, and it's sometimes sarcastic. Musk claims it's designed to be truth-seeking, unafraid of political correctness. He even teased the new model trained on real-time data, including live tweets. XAI is also exploring robotics, search engines, and potentially its own AI operating system. Meta's Llama 3 is an open-source, fast, and surprisingly capable model. Claudia 3 from Anthropic is yet another powerful safety-focused language model, one of the strongest contenders to ChatGPT. Mistral, all the way from France, is small but mighty, efficient, open, and making waves in academia and startups. Every company has a different vision, control, community, conscience, and somewhere in between there, creators are also using AI to compose music, animate films, write novels, and even host podcasts. AI is being used to write books, score films, power therapy bots, and run entire businesses. Some of it is genius, and some of it is kinda creepy. In the book of Genesis, God says, "Let us make man in our image." And now we say to the machines, "Let us make you in ours." But which part of us are we copying? Our intelligence or our brokenness? Paul writes in 1 Corinthians 8, "Knowledge puffs up, but love builds up." You see, that hits different when you're staring into a machine that knows everything but feels nothing. We have to ask, what are we building and why? Are we just scaling intelligence, or are we shaping mirrors that reflect our deepest fears and dreams? And again, Turing once said, "We can only see a short distance ahead, but there is plenty to be done." Maybe AI isn't here to replace us, but to remind us what it means to be human. But besides all of that, what is the promise of AI? AI does have real potential. Detecting cancers months before symptoms show up, reversing climate change through real-time modeling, making education personal, even in remote corners of the world. And the baby steps of this are already upon us, as some countries have already mandated AI integrated education, even at kindergarten. AI could also give a voice to the voiceless through accessibility techs such as prosthetics, translation tools, and also through brain chips, such as the work being done by Neuralink. AI won't save the world, but it might help us see it more clearly. The real challenge, though, can we lead with humility? Can we steward power without letting it corrupt us? The future of AI doesn't just belong to engineers and CEOs. It belongs to all of us. So, that's the arc from math labs to language models, from war rooms to whispering machines. What we build with AI will echo long after us. Maybe machines won't ever have souls, but maybe, just maybe, they'll help us tend to our own. Thanks for tuning into AStellarInsight. If this starts something in you, share it, speak about it, and explore it. Stay curious, stay kind, and never stop wondering.